So today we're going to look at the tangent ratio of right triangles. And before we start, a right triangle is a triangle with one angle measure that is 90 degrees. And that's going to look something like this. Just a normal triangle with this square right here that indicates 90 degrees. Now the next thing we want to look at is that this is going to be a new symbol here. It's a circle with a line through it, and it's called theta. And what theta is just an angle that we're trying to find there. And what we're going to be talking about is applying tangent to the angle theta. And when we're solving for tangent, we can write it out. Tangent, which is equal to tan for a short name, is equal to opposite over adjacent. And we're going to go over that right now. So we have our right triangle, and we want to and our angle theta. And we're also given three letters that we're going to be labeling our triangle with: O, A, and H. O is opposite to theta. A is adjacent to theta or next to it. And H is the hypotenuse. So whenever we look at theta, theta can be at any of the 3 points, or any of these 2 points. And what we want to label now is O, A, and H. So opposite would be this right over here, opposite of theta. Adjacent would be right here next to it. We can label that A. And the hypotenuse is always the longest leg, so we're going to call that H up top. And again, like we said before, tan of theta is equal to opposite over adjacent, which is equal to O over A. We want to keep that over 1. So this is what we're going to need to remember going forward to work on a few problems. Is equal to O over A. So let's go ahead and try out an example. So we want to find the ratio of an angle theta. So we're given the triangle, the right triangle, P, Q, R, and right here is 150. Here is 85. So positive 85, not a negative. And our angle theta right here, which is also equal to angle P. So the first thing that we want to do here is we're going to want to go ahead and start labeling our opposites, adjacent, and hypotenuse. We're going to be doing that for every triangle, labeling it O, A, and H. Now the next thing we can do is write that the tangent of theta is also equal to the tangent of P, because they're the same thing, right over here. So now we can go ahead and set up what we have talked about. So we need to remember that the tangent of P over 1 is equal to opposite over adjacent. So what we're going to do now is substitute in the values. So the tangent of P is equal to 85 over 150. And that's going to be our ratio for the tangent for P. that's going to be that angle measure. So the next thing that we're going to do now is we are going to set up an equation in a similar fashion. So we're given the triangle, we're given this right triangle here with this angle right here that measures 13 degrees. This side length, which is 24, and this side length x, which we're trying to find. So what our first step here should be is to start by labeling our triangles opposite of the angle or theta, adjacent to the angle or theta, and the hypotenuse for the triangle. Now we can write our same ratio. Tangent, this is what we're always going to refer to. Tangent of theta is always going to be opposite over adjacent. And in this case, we know what theta is. Tangent of 13 degrees over 1 is going to equal to x over 24. And now this is something that we've done in the past where you want to cross multiply. And this is when you would plug it into your calculator. Tangent of 13 degrees times 24 is equal to x. And when you are finished typing all that in, you're going to get x is equal to 5.54. And that's going to be this missing side length right here. Now let's look at another example where x will not be in the numerator. So we are given the right triangle right here. We're given 10 and x. And our theta right here, which is 20 degrees. That's all given in this problem. Again, we start off with tan of theta over 1 is equal to opposite over adjacent, but we need to label everything here now. So we know that 10 is opposite of theta. So we're going to go ahead and put an O right here. X is adjacent to the 20 degrees, and this will always be the hypotenuse across from the 90 degree. So now we can start this off as tan of 20 over 1 is equal to O over A, which is also equal to 10 over x. Now we can set this up as tan, and we can replace the middle. 10 over 20 over 1 is equal to 10 over x. Do what we've done before, cross multiply, and you are going to get x times tan of 20 is equal to 10. And then this is where you would just divide 10 by the tan of 20, and you're going to solve for x, and x is going to be around 27.47. And that's going to be this missing side length right here. Now we're going to move on to the inverse tangent, or tan to the negative 1. And we use the inverse tangent to find theta to the nearest degree. So let's go ahead and see an example of this. So we're given the right triangle of P, Q, R, and we're given theta. We want to find theta, and we're given that this side length is 8 and this side length is 17. So the first thing that we want to do is realize that the tangent, negative 1, and now this is going to be different. Instead of plugging in the angle, we're going to substitute in opposite over adjacent to the tangent inverse and set that equal to theta for what we're solving for. So now we can go ahead and label our triangle like we have. 17 would be opposite of theta, 8 would be adjacent, and the hypotenuse stays the same. Now we can go ahead and set this up as tangent inverse of 17 over 8 is going to equal theta. And in this case, theta is going, we want to round here, or we're not going to round. It's going to be 64.79 degrees. So that's what angle P is equal to.